All right, guys, let's continue. We have 1 and 2. I think I'm going to solve maybe 4 more questions. That will be enough for, I would say, getting some idea about optimization problems. And once again, even if we have quiz next week, okay, I'm going to ask all the questions from this. And let's say 80% of the question at least. I may ask maybe 1 or 2 questions from other exercises 4.1 or 4.234, but at least I'm going to ask maybe 4 or 5 questions from this optimization problem. Okay, that's why once again, please practice these questions, these optimization problems. Another example, the figure shows a rectangle inscribed in an isosceles right angle triangle whose hypotenuse is 2 units long. Okay, all right, good. So you see here the rectangle, okay, its hypotenuse from -1 to 1, right? So its length is 2 units. Express the y coordinate of P, that P, in terms of x. All right. And the hint, write an equation for the line AB. Okay, we can write this. Express the area of the rectangle in terms of x. And what is the largest area the rectangle can have, and what are its dimensions? Okay, so I think similar question that we did in question 3. Okay. Number 1, how do you find, actually, what is it? It says isosceles, right? That is a keyword here. Otherwise, we may not be able to find this. It is isosceles. That means that, what is this? These two sides, right? That is AB and the BC, let's say this point is C, they are equal to each other, right? And first, I had to find the length of OB, or we have to find the coordinates of B, so that I can write the equation of the line AB, right? Then I can express y in terms of x. So to do this one, if it is isosceles, that means that this angle is 45 degrees, right? It is 45. And also this angle also 45 degrees. If it is 45 degrees, and also this angle, it must be 45 degrees, right? So that means that if this one is 1, and also B must be 1, right? Because 45, opposite side 1 and opposite side 1. So then what are the coordinates of B? It must be 0 and 1. And then what is the equation of AB, right? What is the equation of AB? Let's say this part A. So that's equal to, if we have y minus 1 over x minus 0. On the right-hand side, we have slope. It is 1 minus 0 over 0 minus 1. Now from here, it is negative, right? So y is equal to minus x plus 1. So that is the equation of this line. Now, particularly, I can just for any point right on this line is expressed by this equation. So then what are the coordinates of P? Then coordinates of P will be, if it is x, what is y? It is 1 minus x. All right. And part B, question B, express the area of the rectangle in terms of x. So if it is x, right? So then what is the area of the rectangle in terms of x? It is length, as see here, half of the length is x. It is length is 2x. And how about it is height? Its height is 1 minus x, right? Or let me just expand this. Here we have 2x minus 2x squared. And see, what is the largest area that the rectangle can have, and what are its dimensions, right? Again, to answer this question, right, we have to use the first derivative test first to find the critical point. So a prime of x is equal to 2 minus 4x, right? And from here, what is it? X is equal to, what is it? It is 4. So 1 over 2, that is the critical point, right? And this one is a critical point. And once again, if you look at here, a double prime of x, right, that's equal to minus 4, it is less than 0. That is concave down. And that's why this x equals 1 over 2, it gives us a maximum value of a rectangle. So what is the largest area the rectangle can have? Now, we can just write our final answer here. So this A maximum will be when x equals 1 over 2. So 1 over 2, 2x, that's equal to 2 times 1 over 2. That is length times and height. What is height? 1 minus x, 1 over 2. So that's equal to 1 times 1 over 2. So that is 1 over 2. That is the greatest, what is it? Possible area of this rectangle. And what are its dimensions? Dimensions are length, it is 1. And how about width? 1 over 2. All right, another question. Question 10, catching rainwater. A 72 cubic meter open top rectangular tank with a square base x meters on a side and y meters deep is to be built. One is top flush with the ground to catch runoff water. The cost associated with the tank involved not only the material from which the tank is made, but also an excavation charge proportional to the product XY. If the total cost is C times 50 x squared plus 4xy plus 100 xy, what value of x and y will minimize it? So we are talking about, maybe that's our ground, right? I don't know, ground. So we are actually making this kind of container at a square base. Okay, that's our container. Okay, the base is square, right? It says, what is it? Square base. So square base, it is x, is also x, right? And how about the height? Height is y. Okay, so here, what we know about this one is solution, part A. Volume. What is volume? It is x squared base times height, right? So that is equal to 72 meter cube. And if the total cost is given by this, what values of x and y will minimize it, right? Now from here, I can express x squared by this, or y. I think we better express y, right? So what is y? Y is equal to 72 over x squared. So now we can express our cost function, the cost function, in terms of only x. So that's equal to 50. And here we have x squared plus 4x times. What is y? Y is 72 over x squared plus 100. Actually, is it correct? Y for xy, and anyway, let me just check one more time. Okay, the question for xy after 2 times. Okay, nothing is wrong. Just to emphasize that this cost and also digging the ground, I think that's why they didn't combine this. So here we have 100 x times y. What is y? It is 72 over x squared. Now, if we simplify this, so that's equal to, here we have 50 x squared, right? And plus, and what is it? I should just calculate it for this. 50 times 4, it is 200, and 200 times 72. That's equal to 14400 over, here we have x, plus, and again, x, they cancel each other, 7200 over x. Let me just combine this. That's equal to 50x squared plus, that is plus 72, right? That's equal to 216,000 over, what is it, x. So that is our cost function. Now we have to find the value of x and y that will minimize it, right? So I need to move to the next slides. Some more space. Okay, so 50x squared plus our cos function is equal to 50x squared plus 216,000 over x, right? 16,000 over x. So we have to minimize this. So this is one. So first we have to find the derivative of this function, that is 100x minus, right, 216,000 over x squared. So that's equal to 0. Now, if you solve this equation, right, take this to the right-hand side and multiply both sides by x squared and divide by 100. So here we have x cubed is equal to 216,000 over 100. Or that's equal to 2160. Then what is x? Then x is equal to, here we have 216, right? It is 216,000. So that's equal to, what is this? 12 times square root of 15, which is approximately equal to, that's why I corrected 2 decimal places. So that is approximately 46.48. Okay. So that is the dimension of this one. Now, how do we know that actually it maximizes or minimizes, right? To do this one, we have to also make sure that by using the second derivative test, right, c double prime of x is equal to 100, and the plus, right, 2 comes to the front, so that is 432,000 over x cubed, right? So at this point, actually, at this point, as see here, c double prime of, what is it? At this point, that is 12 square root of 15. It is positive. It is positive, right? So at the time here, our function concave up, and here we have that point, right? So it minimizes. It has minimum value. What is the question? What values of x and y will minimize it, right? So dot, 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 then when x equals 12 square root of 15, and y is equal to, what is y? 72 over x squared. So that's equal to 72 over x squared. 12 square root of 15 squared, right? So actually, when x equals this, y equals this, it minimizes the cost. Okay. And how about B? Give a possible scenario for the cost function in part A. Give a possible scenario for the cost function in part A. What does it mean? Give a possible scenario for the cost function in part A. So that means that actually if x is equal to approximately, also let me just simplify this one then. So here approximately x equals 46.48 meters. And how about y? Y is 72 divided by 12 times square root of 15 and the squared. That's equal to 1 over 30. So y is equal to 1 over 30. Okay. So when actually our x, right, the depth of the container is this much, and it is not depth, actually the what is it? The length of the base, right? It is this much, and the height is very short. At the time, the cost will be the smallest here. Anyway, guys, move on. Another example, question 12 from this exercise. Find the volume of the largest right circular cone that can be inscribed in a sphere of radius 3. Right? Or also we can actually translate into in different way. Suppose that we have a spherical bowl, right? Or what is a bowl of ice cream or kind of very expensive wood or something, right? So we are going to cut out, what is it? Circular cone from this spherical object, right? but we want our cone to have the maximum volume. At the time, what must be the dimensions of this cone? Dimension means, say, this height and the radius. So find the volume of the largest right circular cone. So that is largest right circular cone that can be inscribed in a sphere of radius 3. Suppose that this is our sphere, okay? And let me just draw a cone inscribed in this sphere. And inscribed means that the top is touching the sphere surface, right? And also base, it is touching actually, what is it? The surface of the sphere. And suppose that the base radius of this cone is x, okay? Now, actually, the upper part is 3. That's why we don't have to use this y here. So this part, right, the distance between the center of this sphere and the center of the base of the cone, let's say this y. Okay, this is the radius. So now, what is the volume of the cone? 1/3 times base area pi x squared, and height. And what is height? It is y plus 3. So we are going to maximize this, right? So what do we know about x and y? As you see here, they form a right angle triangle. So this equation connects x and y. X squared plus y squared, that's equal to 9, or that's equal to 3 squared. Or from this relation, we can find, should I find, I think I better find y, right? Because as here we have x squared. So what is x squared? X squared is equal to 9 minus y squared, so that we don't have to deal with roots. Now, if I just rewrite our volume in terms of y, then here we have v is a function of y is equal to pi over 3 times x squared, and x squared is 9 minus y squared, and here we have 3 plus y, okay, or so y plus 3. So that is our v, right? So now, again, we are just using the differentiation. To do this one, we have to differentiate with respect to y. So this pi over 3 is constant. Let's just keep it here. And we have the product of two functions here, right? The first part is, it is minus 2y. So here we have 3 plus y, plus the second one is just 1. So here we have 9 minus y squared. So this should be equal to 0, right? To find the critical point. So now, if you factorize this, divide both sides by pi over 3, and also notice here that 9 minus y squared is equal to 3 minus y, and 3 plus y, right? Three plus y. So 3 plus y is a common factor. If you factor out 3 plus y, and here we have negative 2y plus, and here we have 3 minus y. So this should be equal to 0. So from here, y should be equal to negative 3, or here we have y should be equal to, what is it? 3y is equal to 3, y should be equal to 1. As this one actually is negative, that's why it is rejected, because we are talking about the length. So what is our answer? This y, right? So when y is equal to 1, and what is x? This x should be equal to, then it is 8 square root of 8, right? So actually it maximizes the volume. How do I know that? Again, to actually verify this one, we had to differentiate this one more time, right? And you will see that at this point, it is negative. I'm just skipping that part as an exercise. You'll do it yourself. Okay. There's one beautiful question here. Again, it's related to engineering or geometry or architecture. A window is in the form of a rectangle surmounted by a semicircle. The rectangle is of clear glass. I'll highlight that part. The rectangle is of clear glass, whereas the semicircle is of tinted glass that transmits only half as much light per unit area as clear glass does. The total perimeter is fixed, is constant. Find the proportions of the window. Find the proportions of the window that will admit the most light. Okay. As how should we understand this question? Suppose that again, as an architect or engineer, right? You're going to make this kind of window. Okay, the lower part is rectangular, upper part is semicircular, and also you want the upper part a bit tinted, okay, a bit darker, so that it does not transmit much light. Okay, that's what we want. And lower part is fine, maybe it is clear glass. And how much tinted it should be, and the question is saying that it actually transmits only half as much light per unit area as clear glass does. Okay. How do we solve this question? Maybe I'm going to ask this question in the mid quiz. Okay. First, we should understand the question. What we are going to find this. Okay. For this window to transmit the largest amount of light, right? What must be the proportions of its dimensions? That means that with rectangle, it has two dimensions, right? It has length and width. And let's just label for now this length and width. And the question is saying that if the area, right? Area means that anyway, if it transmits maximum amount of light, what must be this ratio? What is L over W? What is this? Okay, so we have to find this, because if you don't understand the question, we cannot solve this problem. First, we should understand the question. Then actually, we'll try to get this expression L over W, and through solving this problem. All right, now then let's start. I hope it's clear now. So I'm going to delete this because I'm going to use something else. So suppose that the semicircle, right? It is R, and also this one is R. Then the length of the rectangle should be then it is 2R. Okay. And suppose that it is height of this one. Let's say it is Y. Okay. Also this is Y. All right. And the question is saying that the perimeter is fixed. What does it mean? It means that number one, the perimeter. What is the perimeter? It is the length of the boundary, right? The length of the boundary is 2R, the bottom, and 2 sides of the rectangle. It is 2Y. And the upper part, right? The curved part, that's just semicircle. That is 1 over 2 times 2 pi R, right? So now if I just simplify this 2 is gone, right? And here we have 2. So here we have 2 plus pi, and here we have R plus Y. So actually this thing is constant, okay? That means that if radius is bigger, then Y will be smaller. If radius is smaller, then Y is bigger. Whatever it is, the thing is constant number. And the second thing is, now let me just label the amount of light that is passing through this window, okay? So now how much light is passing through, let's say, this upper part, that is just semicircle, right? So that is 1 over 2 times pi times R squared. Then how about the amount of light passing through this clear glass? That is twice as much as tilted glass, right? And what is the area? It is 2R times Y. So I have to multiply because it's 2 times 2 twice as much as the tilted light. That's why I'm multiplying by 2. So here we have 2R times Y. Okay, so actually that is the amount of light passing through the window, because the amount of light is proportional to the area, right? So we have to minimize this. So number 3, to do this one, first we have to, what is it, differentiate this, right? And to do this one, of course, I cannot do this. Why? Because we have 2 variables. If 2 variables, then I have to differentiate with respect to, what is it, R, or with respect to Y. So now using the first part, I'm going to express either Y in terms of something else. Let me just express Y in terms of R. So from the given, the first equation, right? P is equal to this. What is Y? Y is equal to P minus 2 plus pi times R. Now, if I substitute here, right, this S becomes just a function of R. So here we have pi over 2 R squared plus 4 times R. What is Y? Y is P minus 2 plus pi r. It's too small. All right. Now I can just simplify this further. Equals, here we have, what is it? Pi over 2 r squared. And here we have 4p r minus, and here we have 2 plus pi r squared. Right? Even actually this part I can simplify. I think we have minus 4. Anyway, let me just keep it like this. I want to simplify later. So number 4, now we are going to maximize this, right? So to do this one, we have to differentiate this. S prime of r is equal to the first part. It is pi r. And this p is constant. So here we have 4p minus, how about this part? It is 8, 2 plus pi, and this r. So that thing should be equal to 0, right? So now if you just solve this for r, then what is r? Take everything to the right-hand side, right? Take everything to the right-hand side so we can find r. R is equal to, on the left-hand side, I have 4p over 1 should be 2 plus pi r 2y. Yes, it is 2r 2y. So that is 2 plus pi. Yeah, it is 2y, right? 2y. If it is 2y, then here we have p over 2. Okay, so I need to write here 2 then. So here we have 2. If it is 2, here we have 4. I mean 4r. So here we have 2. And 4 over 2. Again, here we have 2. Thank you. 2, right? If it is 2, if you differentiate this pi r, so this one is 2 pi, 2p, and this one is 4. Right? So here we have 2p then. Here we have 2p, right? And take to this sides. So minus 8 minus 4 pi, right? So 8 plus 3 pi then. This one is 8 plus 3 pi. Minus 8 minus 4 pi minus 3 pi is 8 plus 3 pi. Okay, guys, so this r should be equal to this. So we are going to find the ratio. Now, using the first one, I can find y. Then we can find the ratio, right? So immediately I can find 2r. 2r is equal to 4p over this. Now, if I substitute there using the first equation, right, I can just use this equation and also the second one because we need to find the ratio of this one, right? Anyway, so let's continue. I need a bit more space, unfortunately. I think everything here not enough. Okay, let me just rewrite this p is equal to, what is it? So we have two equations here. Y is equal to p minus, what is it? 2 plus pi r. 2 plus pi r over 2, right? And how about r here? R is equal to 2p over 8 plus 3 pi. Now using this one, what I'm trying to find here is 2r over y, right? I need this ratio. So how can I do that? I'm just going to, what is it? Change p, express p in terms of y and r, right? Now from the first equation, let me just write here, 2y is equal to, what is it? P minus 2 plus pi r. Now from the first equation, what is p? P is equal to 8 plus 3 pi right? Times r over 2. Now, if you substitute here, 2y is equal to, it is 8 plus 3 pi over 2 times r minus 2 plus pi r. So r is a common factor. Let me simplify this. So that is 8 plus 3 pi minus 2 times 2, it is minus 4 minus 2 pi over, here we have 2 and r, right? So that's equal to, what is it? 8 minus 4, it is 4. 3 minus 2, it is pi, plus pi over 2r. So we have to find 2r over y. If you just cross multiply, right? And 2 goes here, we have 4 over 4 plus pi is equal to r over y. Or if I just multiply both sides by 2, here we have 8 and here we have 2. So for the window to transmit the maximum amount of light, right? The ratio of the length of the rectangle to its width must be 8 over 4 plus pi. All right, guys, the last question. I think we have another question. I have two questions actually. Let me solve one more question, maybe another question I can record and share with you. I'm going to actually solve 3 or 4 more questions and share with you. Okay. So the last question, and I'm also tired. Also, you must be tired. That much is enough for today. The trough in the figure is to be made to the dimensions shown. Only the angle theta can be varied. What value of theta will maximize the trough's volume? Now, see here the length, it is 20. Maybe it is inch or meter or centimeter. Let's say it is meter. And it is base area, right? This actual cross-sectional area, it must be like this. Okay, 1, 1, and theta 1. So now, what is a volume? We know that the volume is equal to cross-sectional area times length, right? And the length is equal to 20. I know that, but how about the cross-sectional area? So cross-sectional area, it is, what is this? Oh, so this one is 1. Now we have 2 triangles, right? Also, actually, this is 1. 1. How can it be 1? I don't understand. Uh-huh. Okay. So this one is 1. All right. So suppose that this side is x. Okay. So this side is, let's say this y. All right. Then what is cross-sectional area? Cross-sectional area is equal to 2 times rectangular part. So rectangular part is 1 over 2 times x times y, right? And the plus this actual rectangular part, that's equal to y. Or simply, that's equal to y times x plus 1, right? Because y is a common factor. So now, how can I express everything in terms of theta? Now, if you look at this by the triangle, what is sine of theta? Sine of theta is equal to opposite side. It is x over y. Okay. So now from here, we can express everything in terms of sine of theta, right? And if we just add 1, okay. All right. Okay. So area y, I know x over y. All right. Anyway, so opposite side over, no. Sine of theta is, what is it? Sine of theta is opposite side over hypotenuse, right? That's equal to x over 1, right? And how about cosine of theta? Cosine of theta is equal to adjacent side of hypotenuse, that's equal to y. So then a becomes a function of theta, What is y? It is cosine of theta. And what is x? Sine of theta plus 1. Well, I can just simplify this using trigonometric identities. Sine times cosine, that is 1 over 2 sine of 2 theta, right? So here we have 1 over 2 sine of 2 theta plus cosine of theta. Okay. So now that's a cross-sectional area. So now we can express volume in terms of theta. Cross-sectional area, actually the length is equal to 20, right? Times 1 over 2 sine of 2 theta plus cosine of theta. Or if you simplify, here we have, what is it? Or should I keep it like this? I better keep it like this, okay. All right. Just go right here. And now we have to differentiate, right, to find the critical point. So now if you differentiate both sides with respect to theta, here we have 20. And sine of 2 theta, 2 to cancel each other, that's equal to cosine of 2 theta. Minus, how about cosine of theta? That's equal to sine of theta. So this should be equal to 0, right? Now, if it's equal to 0, let me just write here that is sine of theta should be equal to cosine 2 theta, right? And when sine of theta and cosine of theta, they're equal to each other. But now just keep in mind that the theta is acute angle. When theta plus 2 theta, that's equal to 90 degrees, right? Or pi over 2. That is pi over 2. Pi over 2. So that is theta must be equal to pi over 6, right? See here, sine of pi over 6, that's 1 over 2. That's equal to cosine of 60. Okay. So what value of this maximize the trough, what is its volume? Again, by actually differentiating one more time, okay, you will see that at pi over 6, it is negative. Like, for example, v double prime of theta, that's equal to 20. So this cosine of 2 theta, it is minus 2 sine of 2 theta and minus cosine of theta. And you see here, both are positive, and just take out this negative out, so it will be less than this, right? And that's why this v of pi over 6 gives us maximum value of the, what is it, trough. Okay. Guys, let me stop, okay? Maybe 3-4 questions I'm thinking to solve this and share with you. And that much is enough. I think I'm really tired. Also, you may be tired, okay? Keep practicing. Most probably you may have quiz next week, okay? Let me check our schedule because our Paragon University just announced that they are going to give, announced that Thursday, Friday, Saturday, Sunday, Monday is going to be holiday, public holiday. In public holiday, we are not allowed to teach or give any exam. And after that, we don't have much time till final exam. And that's why, and just prepare, actually just make a plan that you're going to have quiz, okay, next Monday or Tuesday or Wednesday, depending on your section. Okay, practice this optimization problems. Have a good day. All right, see you next time. Thank you. Bye bye.
Goodbye, sir.
Goodbye. Thank you.